In this example, we'll take a look at how Tideway Foundation supports data quality for the CMDB. The CMDB underpins all other ITIL processes and requires high-quality CI and dependency data. Configuration data is generally held in many disparate systems, spreadsheets and databases and so on, and generally it varies in detail and quality. And this information very rarely contains dependency information. Implementing a CMDB is one task, but keeping it up to date is an ongoing burden, and generally users do not trust the data. How does Tideway help? Well, through agentless auto-discovery and dependency mapping, we empower CMDB projects in the following areas. At the initiation of the CMDB project, by improving data quality in the CMDB, which subsequently improves the adoption of the CMDB within the organization, and finally we're often called in to recover failing CMDB projects. Through agentless discovery, Tideway Foundation is able to keep an up-to-date record of all servers, software, business services and their dependencies within the environment. The expensive and time-consuming manual audit is removed from the process. An example business service running across 55 servers would normally take several hundred hours to manually audit, model and reconcile. Foundation's discovery reduces this to an hour. Our standardized automated approach ensures data quality is high, typically above 97%, and importantly we ensure the data is consistent across the environment. Here's an example host that's been discovered using Tideway Foundation. For this host we've discovered the full details for this server, its hardware and the software running and so on. You'll notice at the top left we have a visual indicator of data quality, and at the bottom of the page we have a link to the last discovery accesses, and if there's any discovery or data quality issues they'll be listed here. So we have a full measure of how good the data is that we're capturing. Additionally, through successive discoveries we track history for all nodes in our model. So for this server I can see what's changed over time. So the historical comparison for this host gives me two sets of timestamps, one set on the left and one set on the right. Each one of these numbers represents a point in time. So I can go back in time and see the state of this server at this date. So I can see at this date we had 214 patches and 12 gig of RAM. And on the right, at this later date, we have 218 patches and 16 gig of RAM. So clearly some changes happened here and we're able to keep track of this. Regular discovery and export to the CMDB will ensure all changes that Tideway sees in the environment will be reflected in the CMDB. Data quality and history is also tracked for software components, Oracle, Sybase and so on, and also business services or applications such as trading systems or HR systems and so on. So how does this relate to a business service? So we click through to the business service that server supported. This happens to be a trading application. So here I can see all of the software components and servers that support this business service. And here we have a dependency link to another business service, which is a mail hub. Additionally from here, we have a set of contextual reports. So I can report on all the hosts supporting this business service or all the software supporting this service. So these reports are especially important when support teams are disconnected from the business services they support. One team may only be responsible for the network, another just for the server hardware, and a separate group may be supporting the software. If each team supplying data to populate the CMDB is not using consistent methods, then the data will be inaccurate, leading to incomplete and a low quality data model. Additionally, we have visualizations at our disposal. So first of all, I can take a view of my business service within its own context. These visualizations are not static images. Each time this view is requested, the underlying engine traverses the foundation data model, rendering the visualization with up-to-date as-is data. This is vital for making informed decisions. Here I can see a full dependency from logical application at the top, through the software components that make up this business service, down to the servers, physical or virtual, that make up this service, and finally down to the edge network. I can take a different view of this service in terms of its software dependencies. Again, this visualization is dynamically rendered. This engine has overlaid dependency data onto the basic application structure. This shows dependencies at the software level. Here I can see shared software components between two services, a trading system and a risk engine. If I zoom in, I can see some software-based dependency. I can see my Sybase data server with a dependency to the Sybase XP server. These views are impossible to create and maintain manually. With Foundation discovering regularly, these views are kept up to date and fresh. I can also take a higher level view. What are the business service to business server dependencies? So here I have my business service, the London production instance of Imagine. I can see dependency links out to a mail hub and to a risk engine service. Additionally, I can also recenter on any node in these views. I may be interested in this switch and what's directly dependent upon it. I can recenter. The topology is remapped for me. So here's the switch I recentered on. I can see links to the servers, to the business service, and then spanning out to other services that are supported. So in these types of view, I can begin to see the impact of making any change to any components in the data model. Additionally, here I can see a logical layer, so a cluster here in this case, containing two machines. And here, this happens to be a Sun E10K containing 4 logical servers. This would be the same way that we'd visualize virtual systems, such as VMware and Xen. So the dependency views that we've seen here can all be exported to the CMDB. Foundation ships with several export adapters to a generic CSV adapter, a generic relational database adapter, but also productized adapters to tools such as BMC Atrium CMDB. This includes a full data mapping set to export data for servers, software, business services, and their dependencies into Atrium. Initially, Foundation pushes a bulk update of data to a temporary dataset within Atrium using their Java API. The Atrium node ID is stored against nodes in Foundation's data model, ensuring that we track lifecycle for nodes correctly. Subsequent updates of data contain only changes to nodes that are being tracked. The simple data mapping sets can be easily extended to suit any customizations that have been made to your Atrium model. Our generic CSV and JDBC adapters all ship with data mapping sets, pushing data in the same way to any system of your choice. So managing and populating CMDBs with manual data gathering processes is expensive, labor intensive, and leads to poor data quality, and critical dependencies are often not captured. Foundation's agentless discovery and application modeling ensures that the data gathering process is fast and efficient. Data quality is measured for all CIs, dependencies are captured correctly, and changes are tracked automatically.